So today's notes are on the third day of our surface area and volume unit, and we're going to be talking about volume. So the first thing I want to talk about are rectangular prisms or cubes. Okay, so our formula for the volume of a prism is volume equals length times width times height. And remember, the height is just the distance between the bases. Okay, so we're just going to use our formula. We're going to plug in our numbers here on this one. So we have the length and width of the base, which is 9 and 17, times the height, which is the distance between the two bases, which is 24. If you put that into your calculator, you will get 3,672. And now we're doing volume, so our units are going to be cubed. Okay. All right, so you can pause the video and work number 2, and then you can unpause to check your answer. All right, all I'm going to do is plug in our numbers here for this. We have our length and width of our base, which is 12 and 39, or you could have used 8 and 12. It doesn't really matter. Okay, so you have 39 times 12 times 8. You plug all those into your calculator, you get 3,744 feet cubed. Okay, so those are rectangular prisms and cubes. So let's look at all other prisms. Okay, so now what we do is we have the volume equals area of the base times the height, which is really the same thing that we were doing a while ago, because if you look up here, we were doing rectangular prisms and cubes. And LW here, length times width, that is the area formula for a rectangle. You could also say it's the one for a square, because square is S squared, which is the two sides multiplied together. Okay, so really all we're doing on these prisms is taking the area of the base and multiplying it by the height, which is the distance between the bases. Okay, so looking at number 1. Okay, so I've highlighted the bases here, and they are triangles here. Okay, so and the formula for the area of a triangle is 1/2 base times height, and that's what we're going to be finding right here with this capital B. So I'm just going to plug this in now. So we have the volume is equal to the area of our base, which is 1/2 times the base of this triangle, which is 11, and the height is 5.4. Remember, the height and base of a triangle are perpendicular. Okay, so we have 1/2 times 11 times 5.4, and that is the formula for the area of the base. Now, talking about the height, that is just the distance between the two bases, so that will be 16. Whoops, drawing lines again. Okay. Okay, so the area of that triangle, if I plug that into the calculator, is 29.7. And we'll multiply that by 16. And you should get 475.2 millimeters cubed. Pause the video and work number 2. Okay, so the base of this pyramid, this prisms, are trapezoids. Okay, I've put the formula for the area of a trapezoid up here, 1/2 times the height times the sum of the bases. Okay, so all I'm going to do is fill in now. So we have the volume equals area of the base times the height. So the formula for the area of the base is we have 1/2 times, this is talking about the height of the trapezoid, which is perpendicular to a base. So the height of our trapezoid is 17.9. Times the sum of the bases. The bases here, this is 14 and this one is 36, the same as that one. Okay, so 14 and 36. So I'm just going to plug that in here. And then the height of our prism is just the distance between one base to the other, which here is 25. Okay, so the area of that base, of that trapezoid, is 447.5. Rewrite that, 447.5. We still have to multiply that by 25. You probably put all this in your calculator, that's fine. I'm just breaking it out for you. Okay, So when you multiply those two together, you should get 11,187.5 meters cubed. Okay, so let's move on to page 2. Okay, talking about cylinders. Okay, so the formula for the volume of a cylinder, again, it's still the same as what we're doing with the prisms. Okay, so it's still the area of the base times the height, because the bases of these cylinders are circles, and the formula for the area of a circle is pi r squared. So still the area of the base times the height. Remember, the height is the distance between the two bases. Okay, so let's look over here. We're just going to fill in here. Okay, so we know that the volume is equal to pi. Now, because we do have pi now, though, we are going to get this in terms of pi first, because that is the most accurate answer. All right, our radius is 18, so it's going to be 18 squared times the height, which is the distance from one base to the other. So that is going to be 15. Okay, now remember, I'm going to leave pi alone. I'm going to leave it there and not put it in my answer first. So I'm going to multiply 18 squared times 15, and that gives you 4,860. So you have 4,860 pi inches cubed. Okay, so that actually is the most accurate answer. Just going to kind of make sure that you know that that actually is a very valid answer. This is in terms of pi. Well, and we're also going to get an estimation to 2 decimal places. So in your calculator, type in 4,860 times pi. I do want to go ahead and make sure that we're doing the calculator correctly. All right, so let's look at this. So we have 4,860 times pi, just a second, and then it's right here. And click enter. Okay, so we're going to round this to 2 decimal places. So it'll be 15,268.14. Okay, so I'm going to write that down. So this is an estimate, so it's estimated, that's what that means, approximately. 15,268.14 inches cubed. Okay, y'all pause the video and y'all do number 2, and then check back and see if you got the answer right. Okay, so looking at this, I don't have my radius, I have the diameter, but that's okay because I know the radius is half of the diameter. So we know that our radius is going to be 5.5 because the diameter was 11. So I'm just going to fill in here. So we have pi times the radius, which is 5.5 squared, times the height, which is the height, the distance between the two bases. So it's going to be 21. Whoops. I keep drawing lines. Okay, so I'm going to get this in terms of pi first, because as I said earlier, that is the most accurate answer. So 5.5 squared times 21 will give you 635.25 meters. Oops, I forgot my pi. 635.25 pi meters cubed. Okay, so I do want to make sure, like I said, that you're always getting that answer as well, because that is the most accurate answer. It's before you've rounded or done a decimal estimate. So this is in terms of pi. I'll just label that for you. Okay, so let's get an estimated answer. Okay, so let's do that to 2 decimal places. So in your calculator, you would type in 635.25 times pi, and you will get 1995, so 1,995.70 meters cubed. Okay, now let's look at pyramids. Okay, so the formula for the volume of a pyramid is 1/3 times the area of the base times the height. Okay, remember the height, though, for this one is going to be the distance from the vertex of the pyramid down to the base. It intersects the base perpendicularly. Okay, so let's look at number 1 here. Okay, so we have that we know that the base here is a rectangle. So the formula for the area of the base is length times width. So I'm just going to start plugging in my numbers here. So you have 1/3 times the area of your base, which we know is just going to be 21 times 9. And then times the height of the pyramid, which is 5 yards. So times 5. Okay, before we do this, I want to go through how to do this in your calculator to make sure that you are using the fraction part of your calculator, just so you know how to do it. So let's look at the calculator. Let me clear what I have on here. Okay, so to do the fractions, as I told you to do in class, you see this math button on your calculator, you're going to click that. And you have all of these things that come up: math, number, complex numbers, problem, fraction. I want you to choose this fraction over here, not this one underneath math. That's not the same thing. Over here, I want you to go over to this. Now you can go over to the right, using to go all the way over, or you can just use your left and just go, when you come up, and just go back one. All right, so go over to fraction. I want you to select this one, numerator over denominator. So that's the first one. So I'm going to select 1. Okay, and now it puts this blank fraction here. So I can type in the numerator, which here we had 1. Okay, so type in 1. All right, now to get to the denominator, you're just going to click the down button, and then that's 3. All right, now I want to get out of the fraction, so I'm going to click the right arrow button right there. Okay, and now I want to do my parentheses, so I'm just going to click parentheses. I had 21, and close my parentheses. Then I had 9, close my parentheses, and then I had 5. Okay, so now I should be able to hit enter and get the answer. This whole fraction feature of your calculator saves you from making some careless mistakes, because sometimes when you put them into your calculator, it doesn't work the way you're wanting it to work. So it is best to use that fraction feature. Okay, so let's go back and type in. So our answer is 315 yards cubed. So I'm just going to write that down. We have 315 cubic yards. Okay, y'all pause the video and y'all try number 2. All right, so looking at number 2, there's something missing here. Okay, so before we do anything, we're going to have to find the height of the pyramid. Okay, so to find the height of the pyramid, we already have a slant height right here. I am just going to draw a perpendicular line from the vertex up here to the base, intersecting it perpendicularly. And then I have a right triangle. Okay. All right. So I know that this right here is 25. I know this right here is half the length of the whole side. The whole side's 14. So this piece right here is 7. All I need to do is find the height. So I have a right triangle. If I'm missing a side, I can use the Pythagorean Theorem to find it. So that is what I'm going to do now. Okay. So we have the hypotenuse, which is 25 squared, is equal to the sum of the two sides squared. Okay, so we are going to solve this. So we have 25 squared. I would need to subtract 7 squared from both sides. So 25 squared minus 7 squared is 576. Okay, now to solve for x, I'm going to have to take the square root of both sides. So the square root of 576 is 24. So the height of my pyramid is 24. So now I have all the pieces that I need to be able to go ahead and plug this into the formula. So we have the volume equals 1/3 times the area of the base. Well, the base is a square, so it's just going to be 14 squared times the height, which we just found to be 24. Okay, so plug this into your calculator. Make sure that you use the fraction feature. And when you do, you should get that the volume of this is 1,568 cubic feet. Okay, so pause the video and try number 3. Okay, so in number 3, our base is a triangle. And the formula for the area of a triangle is 1/2 base times height. So here is our, let me highlight that for us. So our base here, right there, okay, is a triangle. Now we are missing something. If we got to find the area of the base, which we do, we don't have the height of our triangle. We have this. We have that this is an isosceles, equilateral triangle. We know that these are all 10, but we don't know the height. Okay, so what we have to do is we have to find it. So what I'm going to do is I'm going to draw a line perpendicular to right there. Okay, and I need to find this. I have a right triangle that I can use to find this. I know that this right here is going to be 5. I know that this is 10. So I'm only missing the height. Okay, so, and again, sorry. Okay, so undo. This is 5. Okay, so I'm just going to use the Pythagorean Theorem. We know that our hypotenuse is 10. So we have 10 squared equals the sum of the two legs squared, x squared plus 5 squared. So now I just need to subtract 5 squared from 10 squared. So we have 100 minus 25, which is 75. So 75 equals x squared. Now I need to take the square root. Okay, so here's the thing. Because I have not finished my problem, I don't want to put a rounded estimated decimal into my problem because I won't get an exact answer. I won't get the most accurate answer. So I'm going to go ahead and reduce this radical, which is pretty easy to do because we know that 75 is just 25 times 3. And we know the square root of 25 is 5. So I'm going to bring out the 5. I'm going to leave that 3 inside there. So the height of that base of the triangle of the base is 5 root 3. So that's what I'm going to plug in here. So I'm going to come back over here to my formula and plug in my pieces. Okay, so the volume, still drawing lines. The volume is equal to 1/3 times the formula for the area of our base here, which is 1/2 times the base, which is 10, times the height, which is 5 root 3, times the height of the pyramid, which is 16. Okay, so I'm going to do this on the calculator with you guys just so you can kind of see it. The first thing I'm going to do, though, is I'm just going to, well, I'll plug it all in. Let's just go plug it all in and see what that looks like. Okay, let me clear this. All right, so again, I want to get my fraction. So I'm going to go back. I got fraction. Enter. I want to pick that first one. So this one is 1/3. So 1/3. Right arrow to get out. All right, I want to open my parentheses here. And I would like to use, well, I'll use parentheses. I'll use the brackets. All right, so let's use brackets. They're right here. I think it's, I can't see it. I think it's there. There we go. Okay, now I have another fraction. I have 1/2 that I need to put in here. So I'm going to go back to math. I'm going to go back to my fraction. I'm going to select that one. And that is 1/2. Okay, and now I've got to do some other numbers in here. I've got 10. So open parentheses, 10, close my parentheses, open them again, because now I have 5 root 3. So I have 5, and then do root 3. And then I want to do a right arrow to get out of my square root sign, and then do another parenthesis, and then I'm going to close my brackets here. So I think that's the, I can't see it, but I think it's the minus sign. Yeah. All right, and then I still need to multiply it by my height, which is 16. So I'll just do parentheses, 16, close my parentheses. And then I'm going to hit enter. Whoops, what did I do? Let's go see what I did. Go to. Okay, so they're not recognizing these. All right, so what we're going to do is we're just going to use parentheses here. Sorry about that, guys. Sometimes calculator error can happen. All right, so let's get right here, and I'll just do parentheses on top of that. All right, now let's try this. Hit enter. There we go. All All right, so your answer should be 230.94. Okay, so let's go write that down. So you get 230.94, and that would be centimeters cubed. So you have cubic centimeters. Okay. All right, let's go to the next page. All right, so now we are talking about cones. Let me move this out of the way so we can see what I wrote. I'll put it right here. Okay, so for cones, you have volume equals 1/3 times pi r squared times the height of the cone. Okay, so it's similar to the volume of a pyramid because you still have 1/3 times the area of the base. Remember, the base of a cone is a circle, and the formula for the area of a circle is pi r squared. So it's 1/3 times the area of the base times the height of the cone. Okay, so h is the height of the cone. So let's go look over this. I'm going to go fill this in. Move that back over here. Okay, so let's look at this. So all I have to do is fill in the pieces here. It's pretty straightforward for this problem. So you just have that volume equals 1/3 times pi. Your radius is 9, so it's 9 squared, times the height, which is 17. Now I'm going to get this in terms of pi because that's the most accurate way to do so. I'm going to say 1/3 times 9 squared times 17. Let's look at our calculator again, just so we're all clear. Okay, so we have the fraction, like that one. So we have 1/3, just use parentheses, times 9, close parentheses, and square that. Make sure you always put your exponent on the outside of the parentheses. Okay, and then times 17, I think that was our number. Okay, and click enter. So you get 459. So I'm going to come back over here, right? And I'm going to say this is 400. The most accurate answer here is 459 pi cubic yards. Okay, so that is in terms of pi. So I'm going to go ahead and circle this and give that as an answer. All right, so this is in terms of pi, but let's go ahead and get the estimated answer to 2 decimal points. Okay, so when you put that in your calculator, 459 times pi, you're going to get approximately 1,441.99 cubic yards. Okay. All right, y'all pause the video and y'all work number 2. Okay, so for this problem, you're going to have to find the height of the cone because we don't have it. We have the diameter of the cone, which is 27, which means the radius is going to be 13.5, but we don't have the height. So I'm going to drop a perpendicular line from the vertex of this cone down to the center of it, of the base, and intersect it perpendicularly. Right now, if you look closely, and I'm going to highlight it for us so we can see it, we have a right triangle right there. Okay, so we know that the hypotenuse here is 22.5. We know that this part, which is the radius of the circle, is 13.5. I'll just label that for us, 13.5. And we need to find the height. Okay, so we have a missing side of a right triangle. So again, we're going to use the Pythagorean theorem. So the hypotenuse is 22.5 squared, and that's going to equal the sum of the squares of the two sides. So if I say 22.5 squared minus 13.5 squared, I'm going to get 324. Okay, and to solve for x, you would take the square root of both sides. So I know that x, or height, is 18. Okay, so now I've got all my missing pieces, and I can just go finish the problem. Okay, so we have that the volume is 1/3 times pi times our radius of 13.5 squared times the height, which is 18. We're going to get this in terms of pi first. So 1/3 times 13.5 squared times 18 is going to give you 1,093. Drawing lines, okay. So 1,093.5 pi cubic kilometers. Oops. Okay, so I'm going to go ahead and circle that. That is in terms of pi. Whoops, my kilometers disappeared. There we go. Okay, so that is in terms of pi. So I'm just going to circle that. Now we'll write in terms of pi out here just so you know. In terms of pi. Okay, so let's get an estimated amount. All right, so in your calculator, multiply those two numbers together, 1093.5 times pi, and you should get 3,400, drawing lines again, 3,435.33 cubic kilometers. Okay, let's move on to spheres. All right, so the formula for the volume of a sphere is 4/3 times pi times r cubed. All right, so looking at number 1 here, all we need is the radius, which we have at 7. So we're just going to go fill this in. We have 4/3 times pi times 7 cubed. And let's get this in terms of pi first, and I would like to show you something. I'm going to look at my calculator. Okay, it's clear what we did a while ago. All right, let's do the math function when we go over to fraction. And we select the fraction selection. All right, so I want to type this in. We have 4 in the numerator. We have 3 in the denominator. And then we're going to multiply this, I'm going to do my parentheses, by 7, close parentheses. Now to do the exponent for 3, you click this button right here. And then you click your exponent. And we're going to get a fraction when I hit enter. 1,372 over 3. That is an accurate answer. Don't give me a decimal, give me the fraction. Okay, so let's go back over here because that is the most accurate answer. Let's go back over here. And we're just going to write, we'll come up here, that we got 1,372 over 3 pi, and that units there are inches cubed, so they're cubic inches. Okay, so that is our answer in terms of pi. That is the most accurate. There is no decimal estimation in there at all. So that would be your answer. Okay, but now we want to get an estimated answer to 2 decimal places. Okay, so let's go back to the calculator. I already have this, right? So all I'm going to do is come over here and put times, and then I'm going to select pi and click enter. Okay, so this gave us a decimal. So we have 1,436.76. So we have 1,436.76 cubic inches. Okay, I'll pause the video and y'all work number 2 and check back to see if you got it right. All right, so in number 2, I gave you the diameter instead of the radius. So if the diameter is 33, we know that the radius is 16.5. Okay, so all we have to do is go plug this in. We have 4/3 times pi times 16.5 cubed. Okay, so if we could put this in our calculator, I'm going to do this with y'all again. It's clear what we had. All right, so we're going to do the math function where we can come over here and grab the fraction feature. And we're going to type in 4 in our numerator, 3 in our denominator, right arrow button. And this is 16, so get my parentheses, 16.5, those parentheses, cubed. So we do this, and enter. Okay, it gave you a decimal this time because this was already in a decimal form. This isn't rounded, this is just a half. It's not several decimal places, you know, so it's okay. We're going to use that. So we're going to go over here, and this is going to be 5,989.5 pi cubic centimeters. Okay, so that is our answer in terms of pi. And so I'm just going to make a note of that, and then we're going to get terms of pi. And then we're going to get the estimated answer. So let's go ahead and put that in our calculator. All you have to do is just say times pi. So it's 18,816.57. Okay, so that's what we're going to write now. So this is an estimation, and we get 18,816.57 cubic inches. Okay, so let's talk about hemispheres. Okay. All right, so looking at this, the formula for the volume of a hemisphere is 2/3 pi r cubed. Okay, so we just need to have the radius. We have it number 3, so I'm just going to go ahead and plug in our stuff. So we have that the volume is equal to 2/3 times pi times our radius here, which is 5 cubed. We're going to get an answer in terms of pi first, so let's look at our calculator. Here what we had a while ago. Okay, so all we have to type in is we need our fraction. So go to math, go to fraction. Okay, so we have 2, go down in our numerator, go down to our denominator, 3. We're not going to use the pi yet because we want to leave it in there. All right, I'm going to open my parentheses, 5 exponent of 3. Okay, so you get 250 over 3. That's what we're going to use. So we come over here, and we have 250 over 3 pi, and that is in kilometers cubed. Okay, so that is our most accurate answer in terms of pi. Okay, so now we're going to get a estimated answer. Let's go ahead and get this to 2 decimal places. So over here, all you have to do is times pi. So it's 261.80. Okay, so let's come over here. It is 261.80 cubic kilometers, or kilometers, however you want to say it. There we go. Okay, y'all pause the video and y'all work number 4. Okay, so in number 4, I gave you the diameter and not the radius, but the diameter is 18. We know the radius is 9. So that's all we have to do is plug that in. So we have 2/3 times pi times 9 cubed. We're going to get that in terms of pi first because that's the most accurate answer. So when you do that, you get 486 pi. Whoops. Again, I'm drawing lines. So sorry. Okay, so you get 486 pi cubic feet. Okay, so now let's get an estimated answer. So you would just multiply the 486 times pi, and you will get 1,526.81 cubic feet. Okay, let's look at the last page. Okay, so what I want you to do, because you should now know how to do all of these problems, they're just, some of them require a little more thinking. I want you to pause the video and go through problem at a time, checking back in after each problem to check your answer. Okay, I'm going to start out number 1 with you. I think the best thing to do is make a plan, and then I want you to go on after that. So look at number 1. A cylinder with a 2-centimeter diameter is drilled through a triangular prism shown on the left. Find the volume of the prism. Okay, so I like to come up with a plan. I think we need to find the volume of the cylinder and find the volume of the prism, and then we need to subtract the volumes. Okay, so now pause the video and go forward. All right, so the first thing we need to do is we need to find the volume of the cylinder. Okay, so I'm just going to label this so we can look at it easier. So the first, I'm going to draw a little line here. Okay, so the first thing I'm going to look at is the cylinder. Okay, we know that is volume equals pi r squared times the height. Okay, so the volume equals pi r squared times the height of the cylinder. So let's just fill in with what we need here. Okay, we have pi. We know that the radius, if the diameter is 2, which is what it says right here, we know that the radius is 1. So this is just 1 squared, which will just be 1. The height of the cylinder is the same as the height of the prism, so it's 14. And we're just going to leave this in terms of pi for right now. Okay, so this is just going to be 14 pi. Okay, so let's move on to the prism. Okay, so I'm going to draw a line to separate here. Okay, so let's talk about the prism. Right, so we know the formula for finding the volume of a prism is volume equals area of the base times the height. Okay, the base here is a triangle. So we know that this triangle is 5, 5, and 7.1. But we don't have a height of that triangle. So we're going to have to find it. Okay, so I'm going to drop a line here that's perpendicular to my base. That's going to be the height. I know that, let me highlight this so we can see it a little better. We need to look at this right triangle right here. Hopefully y'all can see that. And I drew another line. There we go. All right, so again, here is my triangle. Okay, all right, so we know that this right here is 5 because it's the same as this if up here. So I'm just going to label that as 5. Okay, we know that this right here is half of 7.1, so that is 3.55. I'm actually going to move that. I want to work my problem right there. All right, so 3.55. And what we don't know is our height, which is right there. Okay, so I'm missing a piece of a right triangle. So I'm going to use the Pythagorean theorem. I have my hypotenuse, which is 5. So this is 5 squared equals the sum of my two sides squared. So x squared plus 3.55 squared. I'm going to subtract 3.55 squared from 5 squared. Okay, so that gives, let's go do that on the calculator. Okay, so I'm going to say 5 squared, which I know is 25. Oops, I didn't clear this. All right, so 25 minus 3.55 squared gives you this. Okay, so I want to take the square root of that because I want to find x. So I'm just going to go ahead and do that here. And I want to go ahead and just grab that. So I'm going to go and highlight it by clicking the up arrow. And then I'm going to click enter to get it right there. And then I'm going to click enter again to get the answer. So the answer is 3.52. We're just going to do that there. Okay, so 3.52 is approximately my height. Okay, so I'm going to go fill this in. Okay, so the volume of the prism, we need to fill in our pieces here. Okay, so we have that the area of the base we know is 1/2 times the base, which is 7.1. This is the triangle base that we're looking at. And the height we just found, which is 3.52. Okay, times the height of the prism, which is 14. Let's go put that in the calculator and see what it looks like. I'm going to clear this. Okay, so again, I know that I need to put my fraction in here. So math fraction. Oops. Sorry. I thought I hit the back button. There we go. Okay, so I type in, let's put a parenthesis here. Okay, so I type in 1 over 2. Okay, get out of that. And now I'll do another parenthesis, 7.1, close parenthesis, open parenthesis, our height that we just found for that base of the triangle, 3.52. Close our parenthesis, close the parenthesis on this group, and then multiply that by the height of the prism, which is 14, and then click enter. So you get 174.94. So let's go write that down over here. So you get 174.94. Okay, so now what I have to do is I got to take my two volumes and subtract them. Okay, so total volume is going to be, we'll do 174.94 minus 14 pi. Okay, and that gives us 130.96 cubic centimeters. That's the answer. Okay, so let's look at number 2. I want you all to pause it, think of a plan, follow it through, and then find an answer. So number 2, a diagram of Eric's pool is shown on the left. Plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 cubic feet per hour flow rate. Okay, how many hours will it take to fill the pool? Okay, so the height of the cylinder is 4.5, but we're only filling it to 4 feet. Okay, so we need to keep that in mind. So let's look at this. What we have to do is we need to find the volume of the pyramid, knowing that the height is 4 feet, and then we need to divide the volume by 80 cubic feet to get the time, how long it's going to take. Okay, so let's go ahead and work this. We know that the formula for the volume of a cylinder is pi r squared times the height. Okay, well here we're going to switch up the height a little bit because it needs to be 4 feet. So we're just going to have pi times the radius, which the diameter is 27, so the radius is 13.5. I'll write that down. Okay, so we have 13.5 squared times the height, which we're using 4. Okay, so let's get this in terms of pi. So multiply 13.5 squared times 4, and you get 729 pi cubic feet. Okay, so what we're going to do is we need to find the total hours this takes. I'm just going to write down total hours. Okay, so we are going to take 729 pi, and this is cubic feet, and divide it by 80 cubic feet, because it's 80 cubic feet per hour. Now when I do this, my feet cubed here cancel out, so now we're just dealing with time. All right, so the answer that I get is 28.63 hours. Okay. All right, pause it and y'all work number 3, and then check your answer. Number 3, Caitlin must build a sandcastle in the form of a square pyramid for a project as shown to the left. She bought 3 bags of sand, each containing 1,200 cubic inches of sand. Will she have enough sand to build the castle? So let's see. Okay, so let's come up with a plan. The first thing we need to do is find the volume of the pyramid to see how much sand we're going to need for that. Then you're going to find the total volume of the bags of sand. I know that this is volume of the bag because it's in cubic inches. Then we're going to compare the volumes of each, the volume that we need for the pyramid and the amount that we actually have in the bags. And then figure out if she's going to have enough sand to build the castle. Okay, so the first thing I want to look at is I want to look at the pyramid. So I'm just going to label this. Oops, I'm really good at drawing those lines. There we go. All right, so we're going to look at the pyramid. Okay, so I know that the formula for the volume of a pyramid is 1/3 base times height. Area of the base times the height. Okay, so looking at this, I have a square base, so that's going to be 25 squared. So we have 1/3 times 25 squared times the height, which is the distance from this vertex to the base, intersecting it perpendicularly. So that'd be times 18. That's an 8. Multiply all those together, you are going to get 3,750 cubic inches. Okay, so let's look at how many bags, what the volume was of her bags. Okay, so I know that she has 3 bags, and they're 1,200 cubic inches apiece. So I'm just going to say 1,200 times 3. All right, so that will give me 3,600 cubic inches. Okay, so does she have enough sand? We're going to compare over here, which I know you already know your answer because you can see it. Okay, so the pyramid requires 3,750 cubic inches. We only have 3,600 cubic inches, so there is not enough sand. So the answer here would go something like this. Well, it would be better if I could write better. Okay, so she does not have sand. How much more does she need? She needs how much? She needs 150 cubic inches. More. Okay, pause it and do number 4. Okay, number 4, the cylinder to the left contains 2 congruent hollow cones. If the cylinder's height is 20 inches and its diameter is 14 inches, find the volume of the solid. Okay, so we need a plan. We're going to find the volume of the cylinder and of the 2 cones, and then we're going to subtract the volumes. Okay, so let's look at this. The cylinder, we know, is volume equals pi r squared times the height of the cylinder. Okay, so all we have to do is just fill this in real quick. Okay, now we were told some things, although I probably need to label the diagram for you. The height is 20 inches, and we know that the diameter is 14, meaning that the radius is 7. Okay, so now I'm just going to fill in. We have pi times the radius, which is 7, squared times the height, which is 20. I'm going to leave this in terms of pi, which is 980 pi cubic inches. Okay, so let's look at the cones. Draw a line. Okay, so the formula for the volume of a cone is 1/3 pi r squared times the height of the cone. So this is 1/3 pi r squared times the height. So I'm just going to fill in here. Okay, I'm going to leave this in terms of pi too. Okay, we know the radius is 7, and we know the height of the cone is, well, we don't have that written down. But if the height of this whole thing is 20, and these cones are congruent, so the height of this cone is half the whole length, we know that the height has to be 10. Okay, so we're going to leave this in terms of pi. So 1/3 times 7 squared times 10 is going to give us 490 over 3 pi. But there's 2 of them. So because there's 2 of them, we need to multiply this by 2. And so when we do, we get that this is 980 over 3 pi. Okay, so now we have the volume of the cones and the cylinder. So now all we have to do is subtract the volumes. Okay, so let's find the total volume. I'm going to take this, and I'm going to say 980 pi minus 980 over 3 pi. I'm going to get it in terms of pi first. Let's go look at the calculator to see what that looks like. Okay, so clear this. So we said 980 minus, I'm going to do my fraction here. Okay, and this is going to be 980. The denominator is 3. That gives you 1,960 over 3 pi. So this gives you 1,960 over 3 pi, and these are in inches. Okay, so that is the answer in terms of pi. That is your most accurate answer. Let's get an estimate to 2 decimal places. Okay, so I'm going to go back to my calculator. I'm going to say, all right, now I need this to be times pi. So I'm just going to click times pi, enter. So I get 2052.51, and that's going to be my answer. I'm going to go here and write it, 2052.51 cubic inches. Okay, so y'all do the last one, put it on pause, and then check back for the answer. Okay, the Henleys have a silo on their farm to store grain. Assuming the entire space is used, what is the maximum amount of grain that the silo can hold? Okay, so you need a plan. So what we're going to do is we're going to find the volume of both the cylinder and the hemisphere, and then we're going to add the volumes. Okay, so let's look at the cylinder. And we know that the formula for the volume of a cylinder is pi r squared times the height of the cylinder. Okay, so let's fill in with what we have. Okay, we know that the radius here is 22, meaning that, I'm sorry, the diameter is 22, meaning that the radius from the center to the outside will be 11. So we know that that's 11. So we have the volume equals pi times 11 squared times the height of the cylinder, but I have the height of the whole thing. So let's think about this. If from here to here is 11, if we have, let me write that down. I'll draw that for you. If we know that from here to here is 11, what is the rest of it? From here to here. That would have to be 34. So the height of the cylinder is 34. Okay, so we're going to leave this in terms of pi. So just multiply 34 times 11 squared, and you will get 4,114 pi. And that is feet cubed. Okay, so let's leave that. All right, so now let's go look at the hemisphere. You write down hemisphere for us so we know what we're doing. Okay, so the formula for the volume of a hemisphere is 2/3 pi r cubed. So 2/3, that's a 2, pi r cubed. Okay, so let's just fill in the pieces here since we have them. We know that we're going to leave this in terms of pi. So all we have to do is do 2/3 times 11 cubed. Let's go see what that looks like on the calculator. Let's clear this. Okay, so we go to math, fraction, insert. So we have 2/3, and we do parentheses, times 11, and then do a cube. There it is. Okay, so that's 2,662 over 3 pi. Okay, so we have 2,662 over 3 pi. And that is, don't draw lines again. And that is feet cubed. Okay, so let's go look at the total. So what we're going to do is we're going to add those two volumes together. I first want it in terms of pi, and then I want an estimate. So let's look at total volume. Okay, so we are going to say 4,114 pi plus 2,662 over 3 pi. So let's go back to the calculator and see what that looks like. Okay, so I'd already had 2,662 over 3. I'm just going to add to that. I'm just going to say plus 4,114. And that is going to give me I want that in a fraction. Okay, so here's what we're going to do. We're going to get this as a fraction. We're going to hit, actually, let's just go to math. Will that work? Nope. Okay, so let's look at this. Let's do 4,114 plus, let's go to our fraction here, and do 2,662 over 3. It's not wanting to give it to us. It's 15,004 over 3. But, oh well. It's not wanting to work for me. So you should have gotten, I don't know why the calculator wasn't cooperating with me because mine was, just the online one's not. So you should get 15,004 over 3 pi, and that's in cubic feet. Okay, so that is your answer in terms of pi. So let's get it to 2 decimal places. Okay, so all you would do is you would divide those two, multiply 15,004 over 3 times pi. And when you do that, you should get, your approximate answer should be 15,712.15 cubic feet. Okay. All right, so please let me know if you have any questions. Thanks.